Let's go through the process of making a sketch of the derivative of a graph. So let's say that the graph that we're given here is f of x, and we would like to draw the derivative graph f prime. The first thing we want to do is identify important features of the derivative of the graph. So the first thing we might notice is that we have a critical point right here close to x equals -2, another one just to the right of x equals -1, and another one at maybe around 0.6. So from these three locations, we know that we have to have critical values on the graph of f at these x values. So the derivative is going to be 0 at each of these locations. We can also look at the graph of f of x to identify the sign of the derivative on each side of these critical points. Let's start with x equals -2. To the left side, the derivative is negative, and to the right side, the derivative is positive. We can get that just from drawing a little tangent line and figuring out what the sign of the slope is. At x equals -0.8 or so, we can see that the derivative is going from positive to negative. Positive on the left, negative on the right. This coincides with the fact we've identified to the left of this second critical value, the slope is positive. Finally, the critical value at around 0.6, we can see that the derivative is going from negative to positive. The last thing that might be useful is identifying inflection points, because these are going to tell us where the sign of the second derivative changes. This is going to be found by the derivative of the derivative graph that we're going to draw. So it just serves to check that we're drawing this derivative graph correctly. So we can see that around the critical value of x equals -2, the function is concave up. But somewhere between -2 and -1, we have an inflection point because it then switches over to being concave down from, let's say, about -1.5 right here to possibly 0. So somewhere between those two values, everywhere between those two values, the second derivative is going to be negative. Maybe around x equals 0 is where we again perhaps have a second derivative that's 0, and then that graph flips around to have positive concavity. Remember that the signs of the second derivative here are going to tell us what should be happening to the slope of the graph that we're about to draw. So let's get going on this. We know that there is a critical point at x equals -2. We can also see that the derivative is changing from negative to positive on this graph. So we need to draw a graph that goes from negative to positive at x equals -2. So something like this. Okay, we know that there is an inflection point somewhere between x equals -2 and -1, which means that there's going to be a maximum value of the derivative of the graph that we are drawing now. This is because the derivative of the graph that we're drawing needs to change sign from positive to negative at that inflection point. We can then see that this derivative graph has to again go to 0 at the next critical value of f of x. So this graph is going to look something like this. The next place we can see we have an inflection point at x equals 0, and that's where the derivative of the graph that we are drawing right now is changing from negative to positive. So this means we're going to have a minimum value somewhere, let's say around here, and the derivative graph is going to be negative, and then it's going to change to be positive to the right of -2. This is to reflect, to the right of 0, and this is to reflect the fact that the graph becomes concave up to the right of this value. Finally, we know that the derivative graph is going to come back up to 0 to reflect the minimum value of the graph of f of x. So it's going to look something like this, and then that will just continue. So once we have the basic ideas of inflection points, the critical points reflected on our graph of the derivative, then it means that we have appropriately drawn the graph of the derivative as we were asked to do. So I'm going to label the second graph as f prime of x, the derivative of f of x.